Hi everyone. If you're watching this video, you probably needed a little bit of extra help on the quest, chapter 13. So you'll be retaking this test on Tuesday of next week during your flex period. So hopefully watching this review of the test will assist you in doing better and understanding more from chapter 13. Okay, so let's get started. First questions were complete each sentence and with the correct symbol or words and fill in the blanks. So what you were supposed to do basically was you were to say, okay, well, if you have two segments, if two segments have the same what, then they're parallel. So hopefully what you said was if they have the same slopes, that they are parallel. Because technically if you're given a slope, and let's say that slope is 2/3, the slope of the line that's parallel to that is also going to be 2/3 because parallel lines have the same slopes. However, the slope of the line that's perpendicular is what we call the opposite reciprocal. So if it's a positive number, it'll be a negative. If it's a negative, it'll be a positive. And it's the opposite, so that'll be negative. Reciprocal, meaning you're going to flip it upside down, so it's -3/2. Another example might be if I said that the slope was -5. Well, the slope of the line that's parallel to that is also going to be -5. But the slope of the line that's perpendicular, again, there's a 1 underneath all numbers. So the opposite reciprocal for being perpendicular is going to be +1/5. And the reason for that is because any place that you go, let's say we start here and we go, let's say we were to go up 2/3. And instead so you have this line, right, for up 2/3. And I'm looking at this example here. But the slope of the line parallel would also go up 2/3, right? But the slope of the line that's perpendicular would actually go down 3 and over 2. And so if we were to continue this line, going down 3/2 would bring it that way, okay? And that would make our line what we call perpendicular. Okay, anyway, if two lines are blank, then the product of their slopes is -1. So if two lines are perpendicular, and what that means is, you see how these two right here, one's perpendicular and one isn't? The product, meaning 2/3 times -3/2, these cancel, make 1. These cancel, make 1. And the product is -1 if they are perpendicular. The point -3, -4, what that means is you have 4 quadrants. You have quadrant 1, quadrant 2, quadrant 3, and you have quadrant 4. And this is based on our unit circle, which basically starts here at 0 degrees, goes around into the different quadrants. From here, quadrant 1 has from 0 to 90 degrees. Quadrant 2 has 90 to 180. Quadrant 3 has 180 to 270, and quadrant 4 has 270 to 360 degrees. So the point -3, -4, 1, 2, 3, 4, is in this quadrant, and that quadrant is 3. And the last question on this page basically says the equation of a circle, x, I don't know if you can see it, it's a little bit small, but it says x plus 5. Let me see if I can make that bigger. Oops. Let's see. There we go. X plus 5 and quantity squared plus y minus 7 quantity squared is 64. So the actual equation, the general formula for the equation of a circle is this. It's going to be the quantity x minus h squared plus the quantity y minus k quantity squared. Hold on. Equals the radius squared, okay? This is where HK is the center of the circle, okay? HK is my center, and R is my radius. So if you notice, see how there's opposites? So that's a negative H, this is a positive H, negative K, positive K, negative H. Okay, so those are the opposites. So if this says +5 and that says -7, then the center is going to be at its opposite. So if it's a +5, this will be a -5. That's a -7, that'll be a +7. And then the radius is this value here, that's radius squared. Okay, so if I just want the radius, I'm going to square root both sides. And so the square root of 64 is 8. So the next question, number 2, said, if M is the midpoint of CD, where the coordinates of C and M are given. So here's C, here's M. We want to find the coordinates of D. I always suggest that you graph this. I'm not sure if you did or not, but let's just graph this for fun. C is -6, so -6, -3. So here's C, and I'm going to put that there, -6, -3. You have M, which is your midpoint, and that's at 2, -1. So here's M. So that's 2, -1. Now M is your midpoint. And what that means is that's the line that your line goes through that. So if you notice your line, look, C is part of it. So your midpoint, your endpoint that you're looking for is on the other side of M. So you're looking for this point right here, but you don't know what it is. So we're just going to call it, I don't know, XY. Okay, because we don't know what that is. Now, of course, if you do graph this, you can count up and over, okay? But if you don't, there's also another way of doing that, and that is to use the midpoint formula. And the midpoint formula says you add your x's, you divide by 2, you get the midpoint. So for example, if I want to find my x's, I'm going to go -6 plus x divided by 2, and that's going to be my midpoint, which is for x. 2. See, that's my x right there. All right. And then for y, I do the same thing. I'm going to add my y. So you find the average. Add your y. So you're going to go -3 plus y divided by 2 is going to equal my y coordinate, which is -1. So I'm going to cross multiply. When I cross multiply, I get 1 times that, which is -6 plus x, and 2 times 2 is 4, so equals 4. I'm going to add 6 to both sides, so I get x is equal to 10. So my x coordinate, see right there, is 10, meaning over 10. So far, I know that's 10. Now to find y, I'm going to cross multiply on that as well. So I'm going to go -3 plus y times 1. So that's -3 add y is equal to 2 times -1, which is -2. So I'm going to add 3 to both sides, right? And so I'm going to end up getting y is equal to what? 1. And so there's 1. So I have x, and now I have y, and my point that they gave me, the extra point that they wanted me to find, which was D, which is this point right here, is 10, 1. 10, 1. Okay. The next question says if R is 1, 0. So I always like to graph these. So I think it helps everybody if you graph. So this is R, and that's going to be 1, 0. We know that S is 7, 4, so over 7, up 4, so we'll say it's about there. So 7, 4. And then we have T, which is 11, -2, so that's going to be somewhere down here. So T, which is 11, -2. And so what they're asking you is, what is it? Is it scalene, isosceles, or equilateral? Okay, so what your job is to, because they're talking about side lengths, you're going to use the distance formula, okay, in order to figure out, the length of the sides. And once you have the lengths of the sides, you'll be able to tell if it's scalene, isosceles, or equilateral. Okay, so we're going to use the distance formula. If you remember what that is, the distance formula is equal to the square root of, subtract your x's, square that, plus subtract your y's, and square that. Okay, so we're going to do that three times. And so the first one, distance is equal to, we're going to find, let me move this, so let me erase that. Well, actually, I'll just keep going. Let's find SR. Okay, so to find SR, the distance there, we're going to subtract our x's. So we're going to go 7 minus 1, square that, plus 4 minus 0, square that. 7 minus 1 is 6. 6 squared is 36. 36 plus, and 4 squared. 4 squared is 4 times 4, so that's 16. So 36 plus 16 is equal to the square root of 52. Now, I do know that that does reduce, but we don't need to worry about that right now. Now we're going to find the distance of, so we know this distance is square root of 52. ST. So we're going to find ST. So to find ST, again, I'm going to subtract my x's, and then let's see. So 7 minus 11. So 7 minus 11, square that, plus 4 minus -2, and square that. So these make plus. 7 minus 11 is negative 4. The square root of negative 4 is positive 16. 4 plus 2 is 6. 6 squared is 36. So already, again, I have another square root of 52. So at least two sides are congruent. So scaling's gone. The next two we're going to find is RT. So in order to find the distance, or RT, the length of RT, same thing, subtract your x's. So I'm going to go 1 minus 11, square that, plus 0 minus negative 2, square that. And in doing that, what I'm going to get is 1 minus 11 is negative 10. Negative 10 times negative 10 is 100, plus, this makes plus 2. 2 squared, 2 times 2 is 4. So what I get is a square root of 104. And this length here is a square root of 104. So as you can see, it's definitely not equilateral. It is isosceles because we have two sides that are congruent. So that's all you had to say on that. Okay. The next one says the endpoints of the diameter of a circle. So this question right here is asking me, let's see, the endpoints are this. Determine the center, the radius, and also write the equation. So we're going to graph that first. So we're going to go over 3, to the left 3, and up 3. So let's say this is our value here. So here's my center at negative 3, comma 3. And it says, though that's actually not my center, this is my diameter. So that's one endpoint. So the other endpoint is 5, negative 1. So over 5, we'll say negative 1. So here's 5, negative 1. So what this means is they just said it was a diameter. So this distance right here is the diameter of my circle. And what that means is that the rest of my circle, which goes around, is going to do this. Okay. Okay. And so what's going to happen now is we're going to find the distance. So it says here, we need to find this distance in order to find the center, right? So what we're going to do is we're going to find the midpoint first, and then we're going to find this length, because that's going to be my radius. So first, let's find the midpoint, because that midpoint, if you notice, is going to be our center. So you would write, use the midpoint formula to find the center of the diameter. And so let's do that. So the midpoint formula says add your x's, so negative 3 plus 5 divided by 2. And to find my y-coordinate, I'm going to go 3 plus negative 1 divided by 2. So negative 3 plus 5 is 2. 2 divided by 2 is 1. 3 plus negative 1 is 2. 2 divided by 2 is 1 again. So it looks like my center is at 1, 1. And if you remember from the equation that we had before, which was x minus h quantity squared plus y minus k quantity squared is equal to my radius squared, that, remember, this is the opposite. HK is what's given for my center. So that means that this is the opposite. So even though my center is 1, 1, right, my equation is going to start off as x minus 1 quantity squared plus y minus 1 quantity squared. And I got to figure out what the radius is in just a minute. In order to find the radius, we need to find the length of this. This is my radius right there. So I need to find that length. Now, of course, you could actually break this down here and use the Pythagorean theorem. You're welcome to do that. If you have, most of the time, I would recommend that if you have graph paper. Otherwise, what you are going to do is we're going to find the length by using the distance formula. So the distance there is going to be subtract your x's. So we're going to go 5 minus 1. So I'm going this side minus that side. So 5 minus 1 quantity squared plus negative 1 minus 1 quantity squared. And in doing that, 5 minus 1 is 4. 4 squared is 16. Plus negative 1 and negative 1 is negative 2. So negative 2 quantity squared, negative 2 times negative 2 is 4. So I have the square root of 20 is equal to the distance. That's the distance. That's my radius. My radius is equal to the square root of 20. So you would write that here. Radius is equal to the square root of 20. And of course, you can reduce that. The square root of 20 is actually breaks down to the square root of 4 times the square root of 5. Now, the square root of 4 is 2. So that's going to be equal to 2 root 5. Okay, so either one of those were acceptable. But here, what goes here is r squared. Remember from the formula right here, you've got equals r squared, but what you just found here was your radius. I want radius squared. So if this is radius right here, to square that, to find radius squared, I just have to square that and I get 20. Okay. All right, that's it. Next problem says, given these points, determine the following. A slope. Okay, so this one, that didn't give me a value. So this is, for the first one, we wanted the slope of segment AB. The second one, we wanted the slope of segment CD. And I know, see, there's no words here. The relationship of AB and CD. They want the relationship. So what we need to do is to find the slopes of both of these first. So if you remember how to find the slopes, the slope formula basically is this. Subtract, and it's the slope. And a lot of people like call it change in y over change in x, of course, right? But you're subtracting your y's over subtracting your x's. Okay, it's a common mistake. A lot of kids will flip this around, but it's always change in y over change in x. Anyway, so we're trying to find the slope of AB, which is just these 2 points here. So if you subtract your y's, so we're going to go -1. I'm starting right here on the right side. -1 minus 5 over, subtract your x's now, 3 minus 1. And so I get -6 over 3 minus 1, which is 2. And so that's going to be -3. So the slope of AB is -3. Now I'm going to find the slope of CD. All right, so CD are these 2 points here. So again, I'm going to subtract my y's. So I'm going to go -1 minus 2 over -2 minus -3. And so that's going to be -3 over, now the 2 negatives here is the opposite now. Opposite of negative is positive. -2 plus 3 is 1. -3 divided by 1 is -3. So as you can see, both of my slopes are the same. So therefore, if both of my slopes are the same, then the relationship between line segment AB and CD is that they're parallel. Okay. The next question says, write the equation of the circle in standard form by completing the square. So this general form right here. And so you want to find it in standard form. So standard form, again, is this form, x minus h quantity squared plus y minus k quantity squared is equal to my radius squared. So that's what we're hoping for. So what we need to do is complete the square. Now, the first thing you do when you're completing the square is you group your variables that are the same, that are like, not the same, like. So what we have is x squared, and then we have plus 6x. Now I'm going to leave a space, and then I'm going to group my y's. So I have plus y squared, and then minus 2y. And then I see that my -1 is already on the other side, so we're going to leave it there. Okay, and so what we have now is we have to complete the square. Involving completing the square, what that involves is actually making this trinomial, future trinomial, a perfect square so that it factors into a quantity where it's like the same value times the same value. So what happens is you're going to take half of 6, and half of 6 is 3. So this is, you're taking, remember from the quadratic y equals ax squared plus bx plus c. This value here is your a term. Then this value in front of the x is your b term. So this value right here is my b term. So what you're really doing is you're taking your b term and you're dividing it by 2. And then you're squaring that value. Okay, after you do that, you add it to both sides. So that's the whole process for completing the square. So again, we're taking our b term, which is 6. I'll do it down here. So our b term is 6. Okay, we're going to divide that by 2, and now we're going to get 3, and then 3 squared is 9. So half of 6 is 3, 3 squared is 9, and I'm going to add 9 here. But because this is an equation, see the equal sign? Because that's an equation, actually whatever I do to one side of my equation, you must do to the other side. So if I added 9 to the left side, I am going to also add 9 to the right side. Now we're going to complete the square for the y's, because anytime you have a y squared and a y, you are going to complete that square. You're going to finish that off into a trinomial. So half of 2, remember, we're going to take half of 2, and then square it. And so half of 2 is 1. 1 squared is 1. I'm going to add that to both sides. So what I really have now is this plus this equals this right here on the right. If you look at this, this is actually going to factor into a perfect square. See that x plus 3, x plus 3. And then likewise with this, you're going to have y minus 1 times y minus 1. And then here, you're going to get 9. And this right here is going to be rewritten as x plus 3 quantity squared plus y minus 1 quantity squared is equal to 9. And what this does is it gives us a center in our HK formula, right, of the opposite and the opposite. So this is going to be negative 3 comma 1. And don't forget, this value right here is equal to r squared, which means that in order to find my radius, if that was one of my questions, then I need to square root both sides to get r by itself. And so that means the square root of 9, which is 3. So my radius is 3. My center is negative 3, 1. So if I were graphing that, I'd go negative 3, 1. And then I'd go up 3, left 3, down 3, right 3, and my graph would look something like that. Okay. The next question says, given the line x plus 3y is equal to 9, complete the following in graph. So we want to graph that too. Rewrite the equation in slope-intercept form. Well, slope-intercept form looks like this. Y equals mx plus b. All right, that means I've solved for y. So I'm going to take this equation that they gave me up here, and I'm going to solve for y. So I'm going to get the x on the other side first. So I have 3y is equal to negative x plus 9. I'm going to divide everything by 3. And in doing that, I'm going to get y is equal to negative 1/3 x plus 3. And so this is my equation in slope-intercept form. It means that if I were graphing this, I would go up 3, dot, then I'd go down 1, and I would go to the right 3, and then my graph would look something like this, okay? Keep in mind, if your slope is negative, it's always going to go down right. So that's slope-intercept form. Now, going back up to the top, they are asking me for the x and the y intercepts. So I'm going to go back here to where it says x plus 3y is equal to 9. And if I want to find an intercept, right, of course I started at 3. This, if you look at that, that's just 0, 3, okay? But how would I find this intercept? You know, this is obvious because it comes from the intercept that they gave me. But there's another way of finding intercepts, okay? Intercepts, if you notice, see that 0? If you want to find, if you want to find the y-intercept, you would set x equal to 0. So if I want to find the y-intercept, I'm going to set x equal to 0. So there it's gone. So I have 3y is equal to 9. So y divided by 3 is equal to 3. So my y-intercept, see that? So my y-intercept is 0, 3. So y-intercept is 0, 3, or just 3. To find the x-intercept, let me start again with the equation. X plus 3y is equal to 9. To find the x-intercept, I'm actually going to set y equal to 0. So that's gone 3 times. So it's like 3 times 0, right? That's gone. So now my x-intercept is x equals 9. So that actually means that this goes pretty far. It goes more out this way than I had thought. But anyway, that value there is going to be 9, 0. And so the x-intercept is 9, 0. Now, lastly, we have a slope of the line. Now, what's my slope? If you look at your slope is negative 1/3. I want you to make sure that when you make your slope, when you write your slope, that you don't write negative 1/3 x, because x's are never part of a slope. That's a variable, okay? There's not a slope. Slope is a rise over a run. And the slope of the line that's perpendicular, you're going to flip it around. It's going to be the opposite reciprocal. So if I flip this around, it becomes 3/1, right? And I take the opposite of that, now it's 3. So this would just be positive 3. The next question says, given these 2 points, so you have -1, -2. So here's this point T, which is -1, -2. And V, which is 4, 0. So here's 4, 0. So V, which is 4, 0. All right. Write the equation of the line in point slope form. So we actually have this line, okay, and we want to write it in point slope form. Well, they gave us actually two separate points. So pick a point that you want to use. I'm either going to pick this point, and if I do, right, remember what point slope form looks like. It looks like this. Y minus k equals a, or m. A lot of people use m for slope. So we'll use m times x minus h, okay? And that's where hk is the point given. That's a point that's given, okay? And again, just like in a circle, except those were squared, you still are taking the opposite of both of these. So if I were to choose this point right here, okay, and put it into point slope form, which is this right here, all right, I'm going to go y plus 2 is equal to my slope, which I don't know what that is yet, so I'm just going to leave that as a space, times the quantity x plus 1. And if I were to put it in, we use this point right here, I would say y minus 0 equals my slope, which I still don't know what that is, times the quantity x minus 4. Okay, so far I have two prospective point slope forms. Both of these are correct. So what we're going to do is we're going to find our slope. So remember the slope formula? It's the change in y divided by the change in x. All right, so we're going to find the slope of TV. So in finding the slope, we're going to subtract our y. So I'm going to go 0 minus negative 2. See, my y is 0 minus negative 2 over subtracting my x's. So that's going to be 4 minus negative 1. So these make plus, so I get 2. This makes plus, and I make 4 plus 1 is 5. So my slope is 2/5. So I have 2/5 here, and I have 2/5 here. So for this question right here that said put your equation in point slope form, you just had to pick one point or the other, and then plug it into the point. Now, to put this in standard form, what you actually have to do is go through and put it in slope intercept form first, which means first I'm going to solve for y, okay? And after I solve for y, 2, then I'm going to put it in standard form, okay? And so in order to do that, I'm going to choose the left side or the right side. I'm going to start with the right side, and then I'm actually going to do both just to show you that you get the same exact answer. So let's see here for 1 second. I'm going to bring that down there so I can get that out of my way. Okay, so there we go. So to put this one right here in standard form, I'm going to solve for y. Or first, you solve for y. So we're going to go y is equal to, the zero's gone, 2/5 I'm going to distribute. So 2/5 x, and then 2/5 times negative 4. So that's plus 2/5 times negative 4. And so that's going to be y is equal to 2/5 x minus 8 over 5. Okay. Now, if you remember what standard form is, standard form looks like this. Ax plus by is equal to c. And that's where the a coordinate, the a term, right, in front of the x, the a term is a positive integer. Okay. So if that's a positive integer, check, this is going to be in standard form if the x and the y are on the same side. So what we're going to do is first I need to move this to the other side. And in doing that, it's going to become negative 2/5 x plus y is equal to negative 8 over 5. And then once I've done that, I do notice that for this term, my a term, to be a positive integer, okay, I do need to do two things. Number one, I need to get rid of this divided by 5, so I'm going to multiply by 5. And the second thing is I need to lose the negative sign in front, so I'm going to multiply by negative 5. So every term is going to be multiplied by negative 5, every single one of these, okay? And so that means that when I multiply negative 5 times negative 2/5, my 5's are cancel, my negatives are going to cancel, and I'll be left with 2x. And then I go negative 5 times y, and that's going to be negative 5y. And then I'm going to say negative 5 times this quantity. 5's are going to cancel, negatives are going to cancel, and I get the 8. Okay, so what that is 2x minus 5y equals 8. Next, let's do the same thing for this one just to show that I would get the same thing, but that's standard form. So for doing that one, I would go y is equal to, I'm going to move this 2 to the other side and it'll become -2. I'm also going to distribute this 2/5. So y equals 2/5 x plus 2/5 and then -2. Now I'm going to combine these two terms right here. All right, I'm going to multiply by 5 over 5, and so that's -10. So 2 minus 10, again, is -8 over 5, and I get y equals 2/5 x minus 8/5, and that's exactly the same thing I got on this side here. Remember, move the 2/5 over, I get -2/5 x plus y is equal to -8 over 5, and again, in order to get this term right here to be a positive integer, you are allowed to leave the 2 there. You're just not allowed to leave the denominator and the negative sign. So again, you would multiply everything by -5, and then you would get the standard form again. So number 9 says, name the best formula that you would use to prove each scenario. So for this one right here, it says segments are congruent. To prove that two segments are congruent, I would suggest that you use the distance formula. And the distance formula, is distance is equal to the square root of, subtract your x's, x sub 2 minus x sub 1 squared, plus subtract your y's, y sub 2 minus y sub 1 squared. And what this does right here is gives us the distance. Of course, you're starting with 2 points, and any 2 points you can say this point here is x1, the first x and the first y, and then let's say this point over here would be the second x and the second y. So it's just any 2 points. To show that segments bisect each other, you're actually, for this one, you're going to be looking for a midpoint. You're going to use the midpoint formula. And that, if you recall, is to find the midpoint. You're going to add your variables up. So you're going to go x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Okay, and that's going to give you your midpoint. That's going to give you your midpoint. And what that means is basically, if you let's just say we had a shape like a parallelogram. And if I were to find the midpoint of these two corners here, right, those two vertices, and I were to find the midpoint, and that would be here, and the midpoint of these two vertices here, right, which would be here. If I were trying to find the midpoint of both of those, well, and I ended up getting the same value, wouldn't you know then that these actually bisect each other? Okay, that's why you would use the midpoint formula. And then the last thing is to show that two lines are perpendicular, you're going to use your slope formula. But after you use your slope formula, you're going to multiply them. So like to find the slope, so you're going to find a slope, right? And then you're going to take that slope and find the opposite reciprocal of that slope. And if you multiply these two together and you get -1, then the lines are perpendicular. Okay, cool. So then we have label the missing vertices without introducing a new variable. So it looks like here, this is 0, 0, and this is 2a, but remember you go over and then up. How far am I going up? I'm not going up at all. I'm going up 0. This one is, what did it say? It says it's an isosceles right triangle, okay? And what that means is if it's isosceles, these two sides are going to be congruent, which means that this distance right here has to be the same distance as this here. So if this goes over 2a, then this is going to go up 0, 2a. And then likewise, if this is a going this way, and then, of course, you still have to get over here to get up to R. Well, that distance here is the same as this distance here, which is B. So for this value, you're just going to go A plus B, comma, and then I went up C. You just copy that right there. And then the last problem deals with, it looks something like this. It says use coordinate geometry to prove that the diagonals of a parallelogram bisect each other. And we just talked about that. So for that one, we are going to use the midpoint formula, okay? It says label the missing vertices without introducing any new variables. So for this, we had 0, 0. This was DE. So this is going to be D, comma, C plus E. And then, let's see, this is 0C. Okay, so it's a little bit small. So let me see if I could get this a little bigger so I can see it better. Okay, there we go. All right, so now what our job is, it says use coordinate geometry to prove that the diagonals bisect each other. So if my diagonals actually bisect each other, that means this line here and this line here, they're not, I'm not asking you if they're congruent. I'm asking you if you bisect each other. And they're going to bisect each other if they have the same midpoint. So we need to find the midpoint of both of the diagonals. So for ZX, okay, I'm going to try this one first. So this is ZX, right? Okay, we're going to find the midpoint. So we're going to add the X's up. So we're going to go 0 plus D divided by 2. Now we're going to add the Y's up. So we're going to go C plus E divided by 2. And if I can simplify that at all, I'm going to, meaning like 0 plus D is just D divided by 2, comma, C plus E divided by 2, okay? Now remember, we're trying to get the same midpoint. So we're going to, again, find the midpoint now of these two sides right here, okay? So what are those letters? W, Y? Okay, so W, Y. So the midpoint of that is add your X's. So we're going to go D plus 0 over 2, comma, and then add my Y's. C plus E divided by, oops, don't forget this, add my Y's. C plus E plus 0, there we go, divided by 2, because that's one quantity. This is C plus E is one quantity. All right, simplifying that, I'm going to get D over 2, comma, C plus E over 2. So if and then you would write, so if the midpoints are equal or the same, okay, are the same, then the diagonals bisect each other, okay? All right, so the bottom one, it says, is a little bit small, but it says use coordinate geometry to prove that one pair of opposite sides are congruent and parallel. So if I want to prove that one pair of opposite sides are congruent and parallel, I'm just going to pick WZ. So I guess I'll use this side. So I'm going to use this side here and this side here, okay? YX, yeah, that'll work. So I'm going to prove that let's prove that they're parallel first. So in order to prove that they're parallel, okay, so I'm going to find the slope, so the slope of ZW. So the slope of CW, remember I have to subtract my Y's over subtract my X's. So I'm going to go C plus E, subtract C, all over D minus 0. D minus 0. And so I get, let's see here, C minus C is 0. That's gone. So I have E, oops, I didn't write that right. So I have E over D. So my slope of ZW, so the slope is equal to E over D. Okay, that's the slope. So now I need to find the slope of these two numbers here, and it looks like that's xy. So I got to find the slope of xy. So the slope of xy, again, I'm going to subtract my y's. So in order to do that, in order to subtract my y's, I'm going to go e minus 0. So e minus 0 over d minus 0. So d minus 0. And so that minus 0 is just e over d. So it looks like my slopes, are equal. So if my slopes are equal, then the lines are parallel, okay? Now the last two things, I know this is getting a little bit small, but hopefully you do have your test with you or you'll be able to see that on Monday. In order to prove that the sides are not only are they parallel, but they're also congruent, right? Which would make this a parallelogram. To prove that they're congruent, we would use the distance formula. So I'm going to go the distance formula, and I'm going to go same letters, okay, WZ, and so this one's going to be WZ, okay, or ZW. And I'm subtracting my y's, or x's first, and then y. So I'm going to go d minus 0, quantity squared, plus, now this one's a little bit tricky, subtract your y's, c plus e, subtract c, quantity squared. Okay, and let's see what that simplifies to be. That simplifies to be the square root of d squared plus c's are going to cancel, e squared. So what I have is d squared plus e squared. So hopefully the second one that I do, I'm going to get the same distance. Don't try to simplify this. This does not simplify. That's the answer. So the next one we're going to do is xy. We're trying to find the distance for xy. And so we're going to subtract our x's. So in doing that, I'm going to get d minus 0 quantity squared plus e minus 0 quantity squared. That's going to be the square root of d squared plus e squared. Again, that doesn't factor, doesn't cancel, doesn't anything. But what it does do is it does prove that both of my distances are congruent. So let me just say, if this is a parallelogram and one pair of opposite sides are parallel and congruent, then that quadrilateral is a parallelogram. Okay, so I hope that helped you. We just went over the entire quest that you just took about a week and a half ago, and good luck on the second go round. All right, thanks for watching.